And I'm basically talking about how the Allinea tools are being adapted into the ARM ecosystem and providing a consistent environment for taking ARM into HPC. So we are a tools company. We produce a debugger, DDT, and a profiler map, which is part of the Allinea Forge package, or Forge Professional, as it's now become. And we also provide performance reports, which is a lighter weight performance summary. And all of this is designed to provide a consistent experience through the user interface, through the methods, to actually analyze code consistency, correctness, and performance. Now, we pride ourselves on these tools. We've been developing them for quite a long time, and it's really important to us that we have a strong basis of a scalable and a portable framework to develop these tools on, and that enables the data collection. And really, at the heart of all of this, our tools are a data collection and a data presentation service. And that is really key to us, is getting access to the right data that people need to analyze that correctness, that performance for their application on the hardware that they're interested in using, and then presenting that information back to the user in a digestible, understandable way. But we're more than just a tools company. We've been in the industry for just over 10 years, I believe. And so we have a global team, we have industry experience, working with different customers, with different industries, understanding applications, the requirements of users, and what they actually need to make the most of their HPC resources, and providing them with the tools that they need to do that. Now, this has led to adoption of the tools in, I would say, a significant portion of major HPC sites. I think the statistic that's bandied around is sort of 80% of the top 25 of top 500. So generally, we're kind of widely accepted as an industry standard tool for performance profiling and debugging. And this spans a lot of different industries, and that brings with it a wealth of knowledge of the requirements and the applications that are used in those industries. And we hope to bring that knowledge and that understanding into the ARM ecosystem. And to do this, we are more than just providing the tools to customers. We're trying to share that knowledge with people. And we do this through a variety of ways, and I'll go into some of these in a bit more detail later. But the core of it is the training, the webinars, and then starting to look more into the services and the research components to it. Now, why are we here? Well, in December of last year, Allinea was acquired by ARM. And we're really happy about that. This has put Allinea in a really good position because of the way it's been handled. We've always been a cross-platform tools team. And that's not changed, and that has not been asked to change. So going forward, we are still developing these tools across different platforms. And I've got a slide on what that means. But the acquisition really just helps us to strengthen ourselves as a company to make that happen. But it also works both ways. We bring that wealth of knowledge and experience, the understanding of users and their requirements and their codes and the code's behavior into the ARM ecosystem, and can really help further ARM as a company to make waves in HPC. And beyond that, we really are being integrated into ARM as a whole to provide a consistent tools experience with the existing tools, the compilers, the maths libraries that we've already heard presented today. And that's really important. So in terms of cross-platform, yes, we support all the different kind of CPU varieties, accelerators, GPUs. But really, we're using that knowledge, that understanding of application codes, of hardware, to really provide a consistent experience for both the debugging and the profiling when moving between these architectures. And that consistency of tools is really there to help enable ARM as an HPC architecture. By having access to the same profiler, the same debugger, we really hope to get people up and running on ARM hardware as quickly as possible. And that is absolutely key to enabling ARM as a viable HPC platform. Now, using that knowledge, we're really interested in how we can actually enable applications and application users to port to ARM. How can they use the tools that we produce, the tools that the Manchester teams produce within ARM, to get their applications ported and performant on ARM HPC architectures? So we're really pushing the use of the debuggers to ensure you've got the consistency, to make sure you can debug any variety problems that you have coming from different compile environments, from different architectures, and making sure that your application runs how you think it should run. And consistency is absolutely critical. There's no point having a fast HPC architecture if you can't be confident of the results and of your application. So having a debugger running, it's really, really important. The secondary consideration has to be performance. There's little point in going to all of the effort of taking your big production code and porting it to a new novel architecture to then not get the performance out of using that architecture. So having the performance tools, having that level of analysis and the understanding that goes with that is essential. But part of that is also bringing this knowledge and this wealth of experience that I've already been banging on about to the community to enable people to do this themselves, to train others to do it, and to really build an ecosystem and a community around porting and getting performance from ARM hardware by making use of the tools and the teams built around that. So I've kind of mentioned it already, but the Allinea tools don't stand on their own within ARM anymore. They are part of the ARM ecosystem. And that means using them in conjunction with the existing tools and getting the most out of the ecosystem by using all of the different components and making sure that you're actually you're using the right compiler, you're getting that compiler performance, you're using the maths libraries, you're making the most of them, and you're analyzing your application performance. You're really making the use of the specific hardware that you're running on. And so it's really important for us for those tools to fit in there. And so part of what we've been working on is actually enabling that support. Now, this is quite a blank slide, and that's sort of intentional. Everything works. From a debugging perspective, there is no difference. We don't want there to be a difference. If you debug your application on x86 and you debug it on ARM, I don't want there to be a myriad of differences between how you analyze arrays, how you understand your access patterns. All of this information needs to be accessible in the same way. So it is the same. There are no differences to discuss on that. In terms of the performance side of things, okay, there's some subtle differences as to what hardware information is available to the tools. And so we've had to do a little bit of a tweak to provide some different metrics surrounding performance counters. But these are all wrapped up into a nice, pretty CPU metric based on Linux perf for ARM hardware. Now, the focus for this has been really targeting ThunderX2. So we've got that in there, and we're really making sure that that's working. So that's the boring side of things, but as a tool, we've got far more to it. It's starting to become more extensible. A colleague of mine actually gave a presentation yesterday out at a tools workshop entitled Opening Up Proprietary Tools. We're really starting to look at how you can take these tools, open them up, augment them with extra data sources, export your data, integrate it with other systems. And so, although the standard usage for ARM and ARM enabling really should be a consistent user experience, we want to enable that step above, that step beyond, as to what is specific to different user sites. And the end goal with that is to start building a community around this. The number of people here are a real testament to what we're trying to achieve with this, and Gerrant's already mentioned it in his slides. We've got this GitLab instance online where we're trying to collate this information of user experiences. We've started pushing some stuff to the GitHub repo. This is all about how we can share this knowledge, this experience, to ease the process for new users to adopt ARM as a viable HPC architecture. Now, given that this workshop is part of the ARM Research Summit, I just wanted to take a little opportunity to say, as a company, Allinea was very involved in European research projects, and that work's continuing as ARM. This is a selection of the current research projects that we're working on within ARM, and the whole idea behind these different projects is to look at new ways of using tools, new ways of using information, and furthering the community and the tools themselves. So from a profiling side of things, it's how can we collect new information, how can we collect new insight into applications, and what can we do with that information to really help application developers understand their codes. And a component of that is really developing these new metrics that actually represent the data that users are interested in, what's specific to their codes, what do they want to know about the environment that they're running on, be that hardware, be that software, be that system library. What extra information can we provide back to them to help them further their application? So this all feeds back into the tools, furthering the tools and not just towards ARM. You'll see the key point at the top here is the GPU profiling work that's going on at the moment. This is really about how can we make better tools for the community and use those tools to enable ARM as an ecosystem. And there's a lot of interesting work happening on this at the moment, and we're really proud and really excited to talk about it for those that are interested. Thank you very much.